Fractions, fractions, they're parts of a whole. Fractions, fractions, they're what I know. They're equal pieces, they're parts of a pie. Fractions, fractions, they're alright.
In this video we're going to be looking at equivalent fractions. Equivalent fractions are two fractions which may have different numbers but actually represent the same amount. We all know what 1/2 means. It means split a shape into 2 equal bits, then take one of them. But what if we were to split a shape into 10 equal bits instead? How many of those will we have to take so that we've still got a half of the shape? Now if you split it into 10 bits you'd need to take half of those, which is 5. So 1/2 is exactly the same as 5/10. If you took a half of a shape and then took 5/10 of a shape, you'd be taking the same amount. Now the reason for this mathematically is that to get from 2 to 10 you multiply by 5. So on these bottom numbers here, the denominators, you're multiplying by 5, or there is a link of times by 5, and that link is exactly the same on the top. 1 times 5 gives you 5. This is how you tell if you're dealing with two equivalent fractions. Whatever you do to the top number, you must do to the bottom number. If that's true, then the fractions are equivalent. And that's not the only way you could write a half. For example, you could choose any number on the bottom or top. We could choose, 14ths. We're going to split a shape into 14ths. So you'd say to yourself again, how do we get from 2 to 14? Well, that's times by 7. And on the top, if we're going to keep these fractions equivalent, we'll need to times by 7 again. And that gives you 7, because 1 times 7 is 7. Right, let's look at a slightly different one. What if we're dealing with fifths and 15ths? Well, the link between 5 to 15 is multiplied by 3, and if I want to keep these fractions equivalent, to find the missing number I times by 3 on the top as well, and 3 times 3 is 9. What if I kept the same fraction but did out of 50ths? Well, 5 to 50 is multiplied by 10. So on the top I'll multiply by 10 again. This means that the fractions are equivalent, and 3 times 10 is 30. So 3/5 is the same as 30/50. What about if the bottom number is missing, the denominator here? Well, it's the same thing. The link between the top and bottoms must be the same, so we'll look at the link between the top numbers, the numerators. 3 to 21, well that's multiplied by 7, so I'd need to multiply by 7 on the bottom as well. 5 times 7, that's 35. Okay, a different one then. 6 to 36. That is multiplied by 6. And on the top, if I multiply by 6, 4 times 6 is 24. So these two fractions are now equivalent. And one final one that's slightly different. To get from 6 to 3, the link isn't times anymore. It's a divide, but that's okay. It's divided by 2, because 6 divided by 2 is 3. You've just got to make sure again you're consistent with what you do on the top. 4 divide by 2, because that's the rule to keep these two equivalent. 4 divided by 2 is 2. So 4/6 is the same as 2/3. Okay, here's 6 of these for you to have a go at. Try and find the missing number to keep each of these fractions equivalent. Press pause and have a go at them. When you press play, I'll take you through the answers. Okay, here are the answers. For this first one, you're multiplying by 2, so 3 times 2 on the top is 6. For this next one, you're multiplying by 4, so 1 times 4 is 4. For this next one, you're multiplying by 5, and 6 times 5 is 30. This next one down here, you're actually dividing this time, because it's 12 to get to 3. You divide by 4, so 4 divided by 4 is 1. This next one is multiplying by 5. 5 times 5 is 25. And this final one is multiply by 8, you would think, but actually you have to say to yourself, what would you multiply by 8 to get 32? So it's actually easier to think about it going from right to left. This would be divide by 8, so divide 32 by 8 gives you 4. One more thing you have to be able to do using equivalent fractions is reduce fractions to simplest form. The simplest form of a fraction means that you've cancelled all of the numbers down as much as possible to make them as small as possible. So in this one at the moment, 24 out of 40, we could write that in a different way where both numbers were smaller. What we do to do this is look for numbers that go into both 24 and 40. Now these numbers are even, so there's an obvious choice, 2. So we could divide 24 by 2, divide by 2, and to keep them equivalent, do the same thing on the bottom, divide by 2, in which case we'd end up with 12 and then 20. Now this isn't in simplest form again, because there are more numbers that go into 12 and 20. So we can keep going. In fact, we can divide by 2 again, because they're both even. So let's divide by 2, and then divide by 2 on the bottom. And we'd end up with 6, and then 10. And in fact, we can go again. We could divide by 2 one more time and get 3 and 5. Now, at the moment, it's in its simplest form, and the reason for that is we can't divide by any more numbers. There's no number that goes into 3 and 5, apart from the number 1 of course, but if we divided these by 1, you'd end up with the same thing again. So this fraction cannot be simplified any further, so we'd say it's in simplest form. So the answer would be 3/5. Now you could have actually done this one in a slightly different way. In fact, you could have done it a lot quicker, because whilst 2 does go into 24 and 40, there's actually more numbers. 4 goes into 24 and 40. In fact, 8 goes into both 24 and 40. So if we divide by a larger number, let's see what happens. Let's divide by 8. And then same on the bottom to keep them equivalent, divide by 8. 24 divided by 8, that's 3, and then 40 divided by 8, that's 5. Now we know this is the answer because we got it a minute ago, but we got to the answer in one go by dividing by a larger number. So my advice here is, whilst you can divide by 2, and dividing by 2 is easy, the larger choice of your number that you divide by will get you to the answer quicker. Let's have a look at one more then. Well, this one, we've got 12 and 36. Let's just divide by 2 because that is easy. You've got 6 and 18. If you divide by 2, they're still even, so we can divide by 2 again. You'll get 3 and 9 if you divide by 2. Now, I can't divide by 2 anymore because these two are even, but isn't it simplest form? Well, what we need to check is there a number that goes into both 3 and 9? And actually there is. We could divide by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. And this would be our answer. In fact, again, we could have done this in a much quicker step if we started by dividing by 12. So if we went all the way in one go, from here to here, we'd divide by 12, because 12 divided by 12 is 1, and along the bottom, we'd have 36 divided by 12 gives you 3. It doesn't matter how many steps you take as long as you get to the right answer in the end. Here's 6 of these for you to have a go at. Press pause and have a go. Press play and I'll take you through the answers. Okay, here are the answers. This first question, you could divide them both by 5 and you'd end up with 1/3. This next one, they actually both divide by 9 if you did it quickly, and that would give you 3/4. This next one, they both divide by 2, so you'd get 8 out of 15. This next one, I'd divide by 6 and you would get 3/4 again. This next one actually divides by 15, so you would get 1/3. And this final one, believe it or not, divides by 24, so you would get 1/3. Now you probably wouldn't spot that in one go, but it doesn't make any difference. As long as you get to 1/3 as your final answer, you could have divided by 2 first, or 3, whatever number made sense for you.